15.8, where we will be looking at definite integral. All right, so definite integral, it is part of integration, except that we are no longer just finding an equation or a function, but instead, definite integral will allow us to actually find and evaluate an integral. Okay, so you will eventually get an answer rather than, let's say, x squared over 2. You will get like 5, 6, 9, 12, something like that. All right, so definite integral has a link towards finding the area under a curve. We will get to that later on. So let's actually first look at the technique of how you do definite integral. Okay, so let me show you a general rule on how you will evaluate definite integral. So assuming we are going to integrate a function fx dx, and we want to integrate it from a to b. All right, so basically when you're doing definite integral, you're actually finding an integral from a point to a point. Okay, so what you will get is basically fx, big F. This means I've integrated the small f function, and I want to evaluate it between a and b. Okay, and that basically will be fb minus fa. Okay, so you may be thinking, what is going on here? Now, if I were to show you some graph so that you can understand, assuming this is graph fx, okay, some function. All right, by integrating from a to b, essentially what you are looking at is you're looking at a to b point, which is somewhere around here. All right, and what is going on is that you're actually finding the area under this function. All right, that's why you're integrating from a to b. All right, so that is basically what is going on. Okay, all right, so this is the first rule. Let's look at the second rule. If you're integrating kfx dx from a to b, very similar to what we've done before, right? You can always factor out your k, which is your coefficient, not a variable, yeah, only a coefficient in front of fx. All right, and yeah, and then you just basically integrate as usual, following rule number 1. Okay, maybe I'll put here rule number 1, this is rule number 2. All right, rule number 3, very similar to what we've done before. If you're integrating from a to b of, let's say, fx plus minus of gx dx. So similar to the previous example, you can actually split this up into two parts of the function. So you're basically integrating from a to b of fx dx plus minus of the integral of a to b of gx dx. Okay, so I hope these 3 rules are clear for you and that you can use it for various examples. All right, let's try one example. Let's try A. Let's see how we are going to integrate and evaluate that. Okay, so we are integrating from 1 to 2 of x5 plus 3 over x squared dx. Just be careful, we don't have quotient rule for integration, so you cannot do any very crazy technique. You have to do by splitting up into 2 terms, all right? So what this will get you is basically 1 to 2 of x3 plus 3x minus 2 dx. Okay, so I haven't integrated yet. I'm just splitting into 2 terms, separate terms. And now I will integrate, so that will get me x4 over 4 plus, this will be 3x minus 1 over minus 1. All right, and then it will be from 1 to 2. All right, now you substitute 2 in to the function here. So you have something like 2 to the power 4 over 4 plus 3 to the power minus 1 over minus 1. Okay, and then you're going to subtract, not add, yeah, subtract. Now this time around, you're going to substitute 1 in. Okay, so this will be 1 to the power of 4 over 4 plus 3, 1, power minus 1, oops, minus 1 over minus 1. All right, and then you evaluate that, 5 and 1/4, I believe. Okay, now some of you will ask, so where's the plus c? Initially, when we did indefinite integral, you have a plus c. Where's the plus c? Now, you can add the c if you want, doesn't really matter, but know that the c will get cancelled out eventually, right? Because imagine here you have a plus c, maybe I'll just explain very clearly. Here you have a plus c and here you have a plus c. This plus c will minus this plus c, so the c, the constant term, will be eliminated eventually. So in general, when we are doing a definite integral, we don't really need to add a c because we know that it's going to be eliminated. Okay? All right, so you can pause the video right now and try b and c yourself. Otherwise, you can carry on watching this video. All right, let's do part B. Okay, so we want to evaluate from 0 to 5 of root of 3x plus 1 dx. So that basically is 0 to 5 of 3x plus 1 to the power of half dx. Okay, and when we were to integrate this, this would be 3x plus 1 to the power of 3 over 2, because we plus 1 to the power. And please do not forget to divide by the new power, which is 3 over 2. And do not forget to divide by the differential inside the bracket, which is 3. Okay, and we will evaluate it from 0 to 5. You don't have to add the c if you understand what I've mentioned earlier, yeah? So let's evaluate that. I'm not going to do the whole process, but I'm going to just do it quickly here. If I'm going to put 5 in, I should get 128 over 9 minus, if I sub 0 in, by the way, it's not 0, okay? You have to evaluate that slowly. That is actually 2 over 9. Yeah, so be careful. All right, work it out, it should be 14. All right, let me know if you got the answer, if you tried yourself. Okay, great, let's do part C. All right, so this one we're going to integrate from minus 1 to 1 of 10 over 3 minus 2x, oops, here, yeah, square dx. All right, you can factor out the 10. If you do not want to, it's fine as well. This is basically 10 bracket 3 minus 2x to the power minus 2 dx. Okay, so let's integrate that. I think that's not too difficult. You should be able to get 10, 3 minus 2x to the power of minus 1, because minus 2 plus 1 is minus 1. Now, don't forget to divide the whole thing by minus 1, which is a new power, and also the differential inside the bracket, which is minus 2. Okay, yeah, minus 2. No need the plus c. You can evaluate it from minus 1 to 1. Okay, so again, I'm not going to show you the whole process of substitution. You can do it yourself. So you sub 1 in first. You should be able to get something like 5 over 1. Okay, now we're going to minus. You're going to sub negative 1 in, work it out. You should get 5 over 5. Okay, so that should get you 4. Okay, so let me know down in the comment if this 3 example is helpful for you and you have managed to evaluate them successfully. Okay, let's look at more examples. Example 14, basically we are integrating with definite integral of an exponential function and a trig function. All right? Now, if you want to, you can pause first and try it yourself. Come back and check your answer. Otherwise, you can follow through this video. All right, so let's integrate. So if you're integrating from 1 to 2 of 4e to x minus 3 dx, you should be able to get 4e to x minus 3. Do not forget to divide by the differential of the power, which is 2. Okay, and we are integrating from 1 to 2. Work that out. I believe it should be 2e power 1 minus, if you sub 1 in, this should be 2e to the power of minus 1. All right, so at this stage, you can join them into a single fraction. If not, you can just press it in your calculator to get the value. Make sure you keep it to 3 significant figures for the final answer. All right, so I will just join them into a single fraction. So this will be e squared minus 2 over e. Okay, otherwise you can just press this in the calculator and evaluate that. All right, now you can pause and try B now, or you can just watch through if you have done it already. All right, let's evaluate. We're going to integrate from 0 to pi over 4 of 3 cosine 2x plus 5 dx. Now notice that the distance that we're going to evaluate is from 0 to pi over 4. We will not do 0 to like 30 degrees or 40 degrees, because when we are using or we are doing any calculus work involving trig functions, we are always evaluating it in radian mode. All right, so just take note of that. Okay, so let's go ahead and integrate this guy. We should be able to get 3 cosine 2x. Yep, so we should be able to get 3 sine 2x. And we're going to divide it by the differential of 2x, which is 2. All right, and we are going to integrate 5, which should be just 5x. So before was 5 power x to the power 0, so now x power 1. All right, and we are going to integrate it from 0 to pi over 4. All right, let's work that out. You should be able to get, a very long work. So this would be 3 sine pi over 2 plus 5 pi over 4 minus, if you're going to put 0 in, sine 0 is 0, 5 times 0 is 0, so actually essentially everything is 0 here. All right, so you can choose to evaluate that, or you can join them into a single fraction. All right, so I will join them. So sine pi over 2, what would you get? Tell me. So sine pi over 2 is just essentially 1, right? So this will be just 3 over 2 plus 5 pi over 4. Okay, you can join them together into a single fraction. That would be 5 pi plus 6 over 4. Otherwise, you can just evaluate that. Make sure you leave it in 3 significant figures for decimal values. Okay. Now, let me know in the comment if you managed to solve this yourself and you have solved it successfully. All right. Let's try the next example. Example 15. Okay, so we want to work out the integral of 2 to the power 3 of 8 over 2x plus 1 dx. So this we can actually use ln, right? So basically what we have is 8 ln of 2x plus 1, all right? And we're going to evaluate it from 2 to 3. But do not forget, every time you integrated this, you have to divide the whole thing by the differential inside bracket. In this case is 2x plus 1. If you differentiate that, it should be 2. So divided by 2. Okay, so let's work it out. So you're going to sub 3 in. So this will be 4 ln 7, if I'm not mistaken. 7, yeah. And then minus, we're going to sub 2 in. So this will be 4 ln 5, yes, 5. Okay, so now you can join them together. You can factor out, they have the same factor, which is 4. So this will be ln 7 minus ln 5. Okay, so using the ln rule, you can basically evaluate it as 4 ln 7 over 5. Okay. All right, otherwise you can press this in your calculator and just get a decimal answer. Make sure you leave your answers in 3 significant figures. All right, you can pause here and try the next one yourself. Otherwise, you can follow through the next example. Okay, so let's evaluate from 3 to 5 of 9 over 2 minus 3x dx. So this basically will be another ln. So 9 ln 2 minus 3x from 3 to 5. Now do not forget, when we integrate functions like this, we have to divide the function, the integral function, with the differential inside the bracket. In this case, it's minus 3, right? So divide by minus 3. All right, so let's sub in 5. We should be able to get minus 3 ln, let me work it out, that should be minus 13, I believe, right? And then we're going to put in 3, that should be minus 3 ln minus 7. All right, notice that I actually put a mod, because you see, when you ln negative 13 without a mod sign, you will actually get an error. So the mod actually helps to make the negative 13 positive and the minus 7 positive, so that I can actually find the value. Okay, let's expand out. This should be 3 ln 13 plus, sorry, not minus, because minus minus plus, it's 3 ln 7. Okay. All right, and then we can join them together. We can factor out 3 or negative 3, up to you. If we factor out 3, then we will have ln 7 minus ln 13. All right, and that should get you 3 ln 7 over 13. Okay, so that's how you solve example 15. All right, so let me know down in the comment if this video has been helpful, and stay tuned for the next video.